All right, hello, it's Miss Bulky again, and now I'm just going to continue with the video that we had talked about before with scientific notation. So the last video I showed you, we were dealing with numbers that were very, very large. So now in this case, we're just going to reverse it, and I'm going to show you how to do scientific notation with a number that is very, very, very small. Okay, so say in science we are dealing with how large a certain bacterium would be. Well, it would be a very, very small number. So that's why we find very small numbers in the textbook, but we don't want to, again, continue using the many, many zeros because it can get confusing. So we want to put this number in scientific notation. So going back to the same rules that we dealt with before, we know that the end number should be, hold on one second, to a power n. So we know that the number should have in the ones column, it needs to be either greater or equal to 1 and less than 10. Okay, and then if there's any numbers afterwards, we would put them in after the decimal. So in this number, where do we want that decimal to be to follow the rules? So we would look here and be like, well, we know that the number has to be greater than 1 and less than 10. So that means that the decimal should end up being here. So this here should be our number, 6.72. But now we have to figure out how are we going to find whatever this n number is, okay? So from our, it's a little blurry there. From our rules, we know that it's the number that we move the decimal. So in order to get the decimal, which is originally here, and we want it to get to here, what do? We need to move it 1, 2, 3, 4, 5, 6, 7 spots. So we would have to move it 7 spots. But now there's something a little bit different. If I look at this number, 6.72, and I multiply it by 10 to the power 7, it's going to give us a very large number. It's going to actually give us 6720000 until we get to the 7th spot. We want this number to end up being equal to this. So in order for us to get 6.72 to represent this number, what do we have to do? Well, when we looked at our multiplying and dividing, we wanted to get a smaller number. We would actually have to divide by 10 to the power 7. So we would be dividing by 10, 1, 2, 3, 4, 5, 6, 7. So we would be dividing it by 10 million. So we would move our decimal 1, 2, 3, 4, 5, 6, 7. So because we're dividing it by 10 million or 10 to the power, we're dividing, we can put a negative in front of that 7. And that negative would represent division, okay? Because we know that from our rules from before, it needs to be a product of a power of 10. So product means multiplication. But we want to represent that we are going smaller, so we are dividing. So therefore, we put in the negative 7. So I'll give you a little thing. Whenever we have a number that starts off less than 1, the exponent is always going to be negative. So give this number a try here to put it into scientific notation. So I'll give you a minute just to give that a try. Or you could pause it here, try it on your own, and then I am going to walk you through how to do this. And I'm actually going to use black because my green seems to be dying a bit here. So I know that I want the number to be greater than 1 or equal to. So that's where my decimal should be. So how many spots do I have to move to get to 1.043 times 10 to the negative what? How many spots do I move it? Or what am I dividing it by? I'm dividing by 1, 2, 3, 4, 5, 6, 7. Oh, same thing. I gave you the exact same, okay? By negative 7. So let's see if that works. In this case, if I had my 1 here and I would divide it by 7, I'd have to move it 7 spots. So if I had recounted that out, it would be here, it would be the exact same. I divide because I want it to be smaller by 7. Okay, so I'm going to give you one more. If I give you now a number like 32.6 times 10 to the negative 4, what would that look like in standard form? If you want to pause it, you can try it out yourself here, but then if you complete it in standard form, you would want to move this 4 spots. So I would move 1, 2, 3, 4. So I know my 1s would end up being a 0, and I would move it 1, 2, 3, 4. And then I just put down the rest of the numbers. Okay, try one more. Say I have a scientific notation, so it's 8.03 because I know that it has to be, less than 10, so it can't, and greater than 1. So let's do 10. Let's give you a big one here. Minus, let's do 9. Okay, so in this case, I look here and I know if you want to try it yourself first, pause it, then give it a try, and then I will show you how the answer. So this negative represents that I am actually dividing it by 10 to the power 9. Or for, I know the grade 8s, we have gone over this, 10 to the negative 9 also represents 1 over 10 to the 9. And I'm multiplying that by 8.03. So when I multiply 8.03 times the reciprocal, because it's a negative exponent, it would be 8.03 divided by 10 to the 9. Okay, and that's why we're dividing. This is the reasoning for why this rule is working with division. So I would go 0. Now let's start counting our 9s. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because we have to take this 8 into consideration. And 0, 3. So this would be my final answer when I'm dealing with 8.03 times 10 to the negative 9. We know it would be a small number that we are dealing with. Okay, so hopefully that helps with multiplying now by a negative power of 10. I will have one more lesson following this.